Hello everybody. Today we'll be solving Leetcode 2926. It's a hard level problem involving understanding of maps and array manipulation. We'll try my best to simplify it. Let's understand the problem first. Let us consider this particular array. Okay, so what we have to do is we have to select a subsequence from this array such that it satisfies this particular condition. For example, if I select this as a subsequence, index 0 and index 3, is it a valid selection? So 9 minus 3 is 6, which is greater than or equal to the two indices which are selected, which is 3 minus 0, 3. So this is valid. After 9, can I select 10? So 10 minus 9 is 1, which is greater than or equal to 4 minus 3, the indices there. So this can be selected. Then can I select 5 after this? No, because 5 minus 10 is minus 5, which is not greater than or equal to 5 minus 4, which is 1. After 10, maybe I can take 13. So it will give us 13 minus 10 is greater than or equal to the indices being 7 minus 4. So the final sum in this case was 3 plus 9 plus 10 plus 13 of this subsequence. Like this, we have to find a subsequence which is satisfying this particular condition and which gives us the maximum sum. If we carefully observe, there is one simplification which we can do to this particular condition is we get this index to the left hand side and this nums to the right hand side. This will give us nums, and writing it in a short way, ij minus ij is greater than or equal to nums of ij minus 1 minus ij minus 1. What is this equation telling us? It is saying if any subsequence which we select as the answer, in that any element on the right hand side subtracted by its index should be greater than any element on the left hand side subtracted by its index. To understand a bit better, let us convert this particular array to to a new with a new, as a new array where we are subtracting the indices. So 3 minus 0, it is 3. Then 3 minus 1 is 2. 16 minus 2, 14. Similarly, we get 6, 6, 0, 2, 6, and minus 4. So the way we can select the subsequences now from this new array is if I say that, let us say this particular element is part of my subsequence, that means any other element which is part of the subsequence from these should be less than 6. That means this is a valid element, this is a valid element, this is a valid element, but we cannot take 14. Let us see if this holds true. For example, index 2 and 4, can it be a subsequence? So 10 minus 16 is minus 6, which is not greater than or equal to 4 minus 2. So the problem has reduced to we need to select the subsequences here such that it is these values are always in an increasing array, increasing order. So this was the original array given, and this is the new array we got by subtracting the indices. Now we need to select the subsequence from this array such that the elements are in non-decreasing order, maximizing the sum of whatever indices we have selected here. Okay, now let us think in this way. If my subsequence ends at index 0, let me write down the maximum sum here in this array. If it ends at index 0, there is nothing else to select from behind. The only sum is 3. Okay. If my subsequence ends at 1, can I select the subsequence which ends at 0? No, because it needs to be in an increasing fashion. Here, the subsequence ending at 0 is having element 3. So it is only this value, which is 3 again. Now for index 2, I am both these values 3 as well as 2 are eligible to be part of the subsequence ending at index 2. So this sum plus the value at index 2, which is 16. So here we are getting 19. With 6, how many are the eligible values? 14 is not eligible, this index, as this is greater, this is less, this is less. So for 6, it is 9 plus 3, which is 12. Okay, now for the another 6, this is eligible, this is eligible, this is also eligible. We we get the maximum sum over here. So we will be selecting this subsequence where it is ending here. So for 6, it is 10 plus 12, which is 22. This is done. Okay, now with 0, there is no element which is less than 0 before that. So only option remaining is its own value. Now with 2, also there is a 2, another 2 here, which is eligible. So subsequence ending at this 2 is sum is 3 plus the value here is 8. So the value subsequence ending at here is 11. Subsequence ending at this 6 is what all eligible endpoints are present. This one, this one, this one, this one, and the maximum value is present at this particular endpoint, which is 22. 22 plus the current value 13 will give us 35. And finally, for -4, there is no number which is less than -4. So the only option is the current value, which is 4. So the answer for this particular array is 35. We have just done a dry run to get an idea of what exactly is happening. So the algorithm which we just discussed can be solved in O of n square. How? As I go through each of the element, for example here, I traverse every element before this one and see if it is less than 6 and select the maximum sum and keep saving. But this will give us a TLE as our size of the vector is 10 power 5. So O of n square solution will not work. As we have seen, O of n square will give us a TLE. So given any particular index, we are able to find the lower value with the maximum sum in log of n times if we use maps. Let us understand through an example. But before that, let us have a quick recap of the properties of the maps. So in a map, all the key value pairs are stored in sorted array, sorted by default in ascending order. Okay, and there is a function called upper bound which will return us the key, an iterator to the key which is greater than or equal to the past key. So if I call upper bound of 6, it will search in the map if there is any key which is greater than 6 and give me the iterator to that one. But this operation will happen in log of n times, log of n. So using these properties, let us see how we can solve this problem. So we will initialize the map with the first element, which is 3, and there is nothing to compare with. So we'll put as the sum as also 3. There is nothing to select before. Now we'll come to 2. For 2, we'll search in the map, is there any key which is less than 2? In log of n times, we'll find out, no, there is no key. So we need to insert 2, 2 with its value as 3. So we will insert 2, 3. Owing to the map property, we'll write it in the ascending order, that is 2, 3, then 3, 3. Okay, now the thing we need to observe is, because this 2, 3 is present, this 3, 3 becomes obsolete. That means any of these indices here will always find the maximum sum of 3 at the lower key value, which is 2 instead of 3. So we can safely remove this entry from the map. That means for any of these values also, you will get the maximum sum of 3, but for a lower key of 2 itself. Okay, we'll move ahead and now we will consider inserting 14. In the map, we'll search, is there any value less than 14? Yes, 2 is present. So we will take this value 3 and add it with the value present at this index 19. So we will insert 14 and 19. The next value is 6. Again, we'll search in the map. Is there any element? Yes, there is 2 present, which is less than 6. And the value present is 3. So 3 plus 9, we will insert 11, 6 comma 11. So 6, 11. I will just shift these two below. Okay. Now, when the next 6 comes, next 6, it will search again. It will this time find this 6 and the value present is 11 and the value present here is, oh sorry, it should be 12. 9 plus 3 is 12. Okay, now the value present is 12 and the value present here is 10. So it's 22. This would be increased to 22. Now again, if you notice at this particular, for this key 6, we are having a maximum value as 22. Why would I save a higher key with a lower max value? So we can safely remove this index again. Now the next entry is 0 as the key. Any element less than 0? No, nothing is present in the map. So we need to insert 0 with the value as 5. So 0 will come here with 5. This is done. Now we'll come to 2. The element less than 2 is present, which is 2. Less than or equal to 2 is present, and the value present is 3. So 3 plus this value, 8, we need to add. So 2 comma 11. So this becomes 11. This won't be able to erase this one because 11 is less than 22. We'll go to the next number, which is 6. From the map, we can see 6 is present. So we can add 22 plus 13 and that is 35. 22 plus 13. Finally, we get minus 4 and there is no value which is less than minus 4 here and the key is minus 4 comma 4. So we insert minus 4 and value as 4. From the map, we can see the maximum sum we get is here and this is our answer. So this can be done in log of n time as we are able to find the minimum key here in log of n time for every search. And we are making sure that anytime we find the key, there is a maximum value associated with it. For example, if there was a 5 with the value as 40, I would be deleting this value, making sure that the maximum is always present. This is saved in this particular order. Hence, uh, I know it is little hard to understand from just one example. We'll go through another smaller example and see how the map changes. Then we'll go to the coding section of this problem. Let us solve another example. So this is the array which was given to us, and these are the indices. And this array is formed by subtracting the nums minus the indices. 3 minus 1, 2, 5 minus 2, 3, 6 minus 3, 3. So these will be the keys in our map and we'll be saving the maximum sum. Okay, let us do a dry run once more time. We'll initialize the map key value. The first element is just 3 and 3. Now we move to the next second element, which is 2. Is there any key less than or equal to 2? No, it's not there. So we need to insert 2 comma 3. 2, 3 is inserted. I will move this one below. Okay, so this is our current map. As we can see, this 2 is less than 3, but it is having a sum which is equal to this one. So we can safely erase this particular 3. We'll go to the next index. So here it is 3. And from the map, we can find a smaller element, which is 2, having a value 3. So we can add 3 plus the value sum present is 5, which is 8. We can add a 3 comma 8. Nothing would be erased as the order is correct. Now the next element is 3. From the map, we'll again find 3 is present with value as 8. So we'll add 8 with this particular value 6, 14. So 8 plus 6, 14. We will insert 14 here for index for key 3. And this is the answer. So this is the logic behind. We will go ahead for the coding section now. So let's see how to code this problem. First, I will define a vector. This vector, we will save the value minus the indices. So for int I is equal to 0, traversing the nums start size I plus plus, we will push back the value of nums of I minus the index. Okay, so these values will be used as key in the maps. Okay, let us define the map of, we will use long. Let's write it as M, and I will initialize the map with the first element, that is M of AR of 0 is equal to nums of 0. Okay, we will also initialize int min as a key and the value as 0. This we are doing this because we are using the upper bound function, and we'll move behind the iterator. We'll see later where it comes into picture. We'll show. Okay, and I will define this long as well as define ll as long. Okay, now our map is also initialized. Now for each index, int I is equal to 1, is less than start size I plus plus. What we need to do is, first I'll get the key as array of I. Now, if this key is already present in the map, it is m dot find key. Okay, if this is not equal to m dot n, then we'll set the value of key as the maximum of which all things. First is the nums of I, comma max. There are maximum of 3 elements, that is the previous value, previous key, and the sum of m of key and the current nums of I. Okay, this we have put like this because nums of I can be negative as well. That's why there are 3 cases. It's either nums of I or the previous value or sum of the previous value with the current nums of I. I will convert this as long as well. Okay, so my key is set. If the key is not present in the map, that it is coming for the first time, now we need to find, is there any value less than the current key? So I will write it as current iterator equal to map dot upper bound. Okay, upper bound for the current key. Now the upper bound property is it will give you greater than the current value. So we want just less than that. So current iterator, I'm doing a decrement operator on this. Now here, if current iterator is equal to m dot begin, that means that this is the reason why the int min was added as a key, that if I do a decrement and it was already pointing at m dot begin, it would have become undefined address. Hence, now if it is pointing to m dot begin, I can say that there is no key which is less than the current key. So I can directly insert this one, m of key is equal to nums of I. Okay, else that means there is a key which is present which is less than the current key. I will define a new int long called sum, which is again the max like the previous one, long of nums of I, and we will get the current iterator's second value. That means our sum with adding it to nums of I. Okay, I will just make it as a long as well. Now we insert the key with this new sum. So our insertion is done, but we also need to eliminate eliminate the cases where the key is bigger but the sum is smaller. So we will get a iterator it, which is nothing but m dot upper bound of the current key. Okay, whenever this iterator is not equal to m dot n, that means not at the end, and at the same time this iterator's value should be less than or equal to our current value. our current new sum. Okay, that means as I'm initializing it here and I'll be moving forward, owing to the maps property, all the keys would be greater. But if its value is less than the current key, I want to remove it from our map. So now in from C++11, we have this m dot erase function, which will be returning you the iterator to the next element after it is being erased. Earlier it used to return nothing. So now it is returning this one, so we can use it directly. And be careful that whenever we are modifying in the maps, we do not do a iterator plus plus here, but we would rather use this particular approach. Because whenever we do marrays it, this it becomes invalidated, and later there wouldn't be anything to do a iterate increment on iterator. So here it will be already incremented and it will move to the next iterator. So very good. Finally, after all the for loop runs, we have to return the last element. So reverse begin second value. Okay, let's see if it runs. Oh, sorry, not the value, second. Okay, let's submit. Okay, it is accepted. There were few important concepts which I learned during this problem. One was how to modify the map while I'm deleting an element from this one. So dynamically the map is changing at the same time I'm traversing it. So this part, and also insertion of this one was a error from my side. Like initially I did not, but wherever I was doing this particular step, that is current iterator minus minus, and I was checking if it was equal to m dot begin, but it was already out of in bad state. So these two were the mistakes which I made multiple times, and these were the new learnings. Hope it was an interesting question. Thank you, everyone. Please like, share, and subscribe.